The first section that we're going to cover is 11.4, and it is on drawing organic molecules. We're going to use in this class 3 different methods for drawing. And the first one is the Lewis structure, which you learned about in Chem 121. So we will review it a little bit. Second method is the condensed structure. Which will be new. And the third method is the line structure. Line structure is sometimes called a skeletal structure, or sometimes called a bond line structure. So you could see it called any one of those 3 things. So let's start with the Lewis structure. In 121, you learned how to take a molecular formula and from the molecular formula draw the Lewis structure. The Lewis structure, as you know, is a representation of the molecule that shows all the atoms in the molecule, and it shows all of the bonds that hold the atoms together. Now, we're not going to review how to come up with a Lewis structure like you learned in 121 because we won't be using that skill in this class. We're going to draw a Lewis structure of a pretty big molecule. So this is a chain of a hydrogen and then 5 carbons in a row and then 1 more hydrogen at the end, and they're all single bonded together. And all of the carbons also have 1 hydrogen we're going to draw sticking up, and they have another hydrogen that we're going to draw sticking down. So that's a Lewis structure. We can see all 5 of the carbon atoms, C5, and we can see all 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can see all 12 of the hydrogen atoms. All the atoms and all of the bonds are shown. That's a really cumbersome way to draw molecules. Even something as small as C5H12, that Lewis structure takes up a lot of space. And since most of the molecules that we're going to be looking at in this class are pretty big, we need to find a better way to draw molecules than that big, bulky Lewis structure. So one of our methods that we're going to use quite a bit is called the condensed structure. In the condensed structure, we are going to still show all the atoms, but we might not show all of the bonds. So we're going to leave out some of the bonds, or maybe even all of the bonds. We know that they're still there. We're just not going to take the time to draw them out. So what we're going to do is take this Lewis structure, this C5H12 Lewis structure that we've already drawn, and we're going to turn that into a condensed structure. And the way that we turn a Lewis structure into condensed structure is we just kind of read the molecule from left to right. We just take a look at what we can actually see. So when we're looking at this molecule, the Lewis structure, the first thing that we see is this chunk of CH3s. And the next thing that we have is a chunk of CH2. And then we have another CH2 chunk and 1 more CH2 and then another CH3. The condensed structure, we're just going to write out these chunks that we see in order that we see them. We have a CH3 first, and then we have a CH2, and then we have another CH2, and another CH2, and then we end with a CH3. This particular condensed structure, we do see all the atoms, but this one, the way that we've drawn it, we don't see any of the bonds at all. And so you probably understand where the name condensed structure comes from, because we've taken this big, bulky Lewis structure and we've condensed it down to something that's smaller and easier to write. But notice that the condensed structure still shows us how the atoms are connected. So even though a condensed structure might kind of look like a molecular formula, C5H12 is the molecular formula. The condensed structure gives us a lot of information about the arrangement of the atoms in the molecule. The condensed structure tells us that it's a CH3 that's attached to a CH2 that's attached to a CH2 that's attached to a CH2 that's attached to a CH3. The molecular formula does not give us that kind of information at all. It just tells us how many atoms we have, and that's it. So here are some other ways that you can write condensed structures. Maybe we wanted to show some of the bonds. One thing that's kind of common is for people to separate the chunks that I circled in green, separate them with a bond like this. So in this condensed structure, these lines that we're drawing, these are the carbon-carbon bonds that are being shown. So maybe somebody might want to represent it like that. Or maybe there's something interesting about some of the carbon-hydrogen bonds. So maybe a person might want to draw the molecule like this. So here we're just showing some of the carbon-hydrogen bonds. I don't know why we might want to see those carbon-hydrogen bonds, but maybe we have a reason. Another way that people can draw a condensed structure, get ready for this, if you have CH2s that are in sequence, that are all stacked together, you can put the CH2 in parentheses and follow it by the number of CH2 units that you have. So this notation here means that we have 3 CH2s that are in sequence or in a row. That's a supercondensed structure. The bottom line is, with a condensed structure, we have to write the atoms in a way that reflects how they are connected in the molecule. So this point right here, we still represent the way that the atoms are being connected. And the other point with this is that there's no actual rule about how you draw a condensed structure. You get to choose which bonds you leave out and which bonds you show. And it's just totally based on your personal preference. There isn't ever going to be any type of rule about which bonds you need to show. So the third method of representing molecules is the line structure or the skeletal structure. And I'm going to do that one in a separate video.